Nice. So I worked out the size of this presentation earlier today on my laptop screen, and this is both square and much smaller. We'll see how the formatting works. I think we may have some off-the-screen slides. So I'm Dan. Yeah, it's great to be here today. This is really awesome. So quick show of hands, how many of you have built a web application? Good, good, I'm in the right room. How many of you have built a web application that communicated with the server without refreshing the page? So a single page application, Ajax, XHR, good, excellent. How many of you have done that using WebSockets? Okay, and how many have done that using sockets or something like sockets other than Socket.io? Okay, cool. This is a good group for the talk that I'm about to give then. So what is a WebSocket? That is a good question. A WebSocket is a lot like, can you hear me? I should ask you this before I long chin. I was sitting in the back earlier, and I know I don't project very well, so I think I need to force my voice out here onto you. A WebSocket's a lot like a pipe. So usually when you're connecting to the server from the client, it's kind of like you're sending a truck, right, over to the server. It's got some data on it, and then maybe the server sends you a truck back with some data. But we don't really want trucks. We want pipes, right? We want to pipe directly from the client to the server. We want to turn our network into kind of a series of tubes, if you will, with these pipes that transfer things around, right? And why would you want to turn it into a series of tubes? That's a really good question. So maybe you want to have a communication with the server of some kind, like a conversation where you're asking it questions and it's giving you answers. Maybe you want to talk to it more directly than just pinging it every now and then, making these long-running connections. Real time. Real time. This is a good buzzword. Put it on your website. Some people will pay you more if you say real time. Yeah, those are all, yes, that's true. So here's some use cases. And this is a slide that goes off the screen. I tailored this so nicely, and all of the lines were on the screen. They were fitting, single line per bullet point, sans bullets. All right, so we can't even scroll. This is so terrible. All right, I will scroll and select, and you'll get red on green. This is amazing. Yeah, so here's some use cases. You want to load up an application. So what do I mean by that? I mean, we want to take our browser and point it to a URL and get source code from that server and bring that source code up to our browser and execute it locally. When you go to a website, you are loading an application on your machine. This is not the original metaphor of the web. The original metaphor of the web is document-oriented. When you go to a website, you're getting a document and loading that onto your local machine. It's not what we do anymore. Now, because JavaScript runs in the client, we get an application, and we load it onto the browser, right? This is really important that you understand that. What the web has enabled is for you to go and run applications that are completely untrusted from sources that you don't even know, that you've never heard of before. You go to their website, they load an application onto your computer, and you run it locally. This is astounding. You would never do that, right? You would never go and find an application on some forum somewhere and download it and run it, right? All of you in this room are smart enough to know that you don't do that. But you do that with web pages all the time. Every time you go to a website, if there's any JavaScript at all, you're running an application that they've written locally. This is amazing, right? That we can do this and do it safely and do it powerfully, right? These applications they're sandboxed, but they're not hamstrung. We have huge amounts of power, right? So we want to load an application, then we want to tell the server something. Now we can do that by making a regular old HTTP request, get some answers back, but that requires reloading the entire application. So maybe it'd be nice if we could do that without reloading everything. Most of you already know how to do that. You raised your hands for that part. Maybe we want to ask the server a question and get an answer back. Maybe we want to get a notice from the server. That would be nice. So in this case, it's not us on the client saying, hey, server, give me an answer. It's the server saying, hey, something came up. I want you to know about it. And it's initiating that. We want to send a message to another client, perhaps, or maybe we want to send a message to lots of other clients. So here's this nice graphic that I made that you will like. So we have a server over here, and we have your client over here. There are lots of ways to send a message from the client to the server. One that we mentioned was an HTTP request, and we can get a response back from the server. That's what we do to load our application. We can also use an XHR request. This is what you use when you call jQueries.post, or when you're using any type of AJAX-y connection. And we can do comedy things like a JSON-P request to a different server. This allows us to get outside of the single origin policy sandbox that only allows you to connect to the server that installed that application initially, right? It also opens up a backdoor if that server that you're connecting to is untrusted. So let's stay away from that if we can in the future. There's lots of ways to have the server give you information. You can use various comedy things like forever frame or JSON-P. We can open up a long-running XHR request, and then when the server gives us a response, we just open up another XHR request, right? So these are all techniques in the past that were used to get around the fact that there was no way to have a conversation with the server. But what WebSockets do is to give us a full duplex connection. That means both sides can send information at the same time. It's bidirectional. I guess that goes without saying if it's full duplex. And it's really the only technology out there that does this. There's a bunch of little technologies here that I won't even bother to highlight because they're evil and bad, and most of them don't work anymore anywhere, right? They were good ideas at the time, but WebSockets has replaced all of that if you want to have a conversation with the server. And it's really the only way to do that. So let's look at those use cases again. Loading an application. We have to use an HTTP call to do this, right? To get that initial page load. And actually, so when you're thinking about building a single page application, which you're here today, you're learning about the mean stack. The mean stack is all about single page applications that are very responsive. This is a really good thing. But going from a document-oriented view of the web, which we started with 20 years ago, to an application-oriented view of the web where we've got forms and now we've got some responsiveness on the server side, but every time you want to send data, you're sending it using a form. Maybe there's a little bit of JavaScript in there to do some light validation or something. But you're always making this call and response back to the server. And now, to single-page applications, something has happened along the way. In those first two cases, where you're just loading a document, or you're communicating with the server by this call and response of HTTP request and response, you don't have any state on the client. Not having any state is a really good thing, because state is really, really hard to deal with. State is the enemy of simplicity. So if your application is very simple and your state is very simple, it's fine. But as soon as your application starts getting complex, then your state gets complex, and you have to deal with the fact that it changes over time. And that means that your functions will give you different answers when you give them the same inputs. They give you a different output depending on when you call them. This messes everything up, right? This is really hard to reason about, especially if you've got states that are overlapping in complex and conflicting ways. So, having said all of that, if you can divide a complicated application, if your application's simple, you can do whatever you want, right? If you're writing small programs, you can write them any way you want, and they'll work fine, it's beautiful. You get a simple application, do whatever you want to do. If you're writing a complex application, think about trying to decompose it into these single-page application silos that don't share state with each other, and then reload between those. There's no shame in that, right? If you can limit the state that you're putting on the client and limit the complexity that you have to deal with in terms of that state, that's a win. So if you go from one area of your application to another, and that's a full-page reload because they don't share state, that's a very good thing. Web components actually enable us to do this in a more compartmentalized way, where you can have state inside a particular piece of your client-side application that's sort of compartmentalized from everything else. So this is a way to get some of those benefits while still sort of sharing state, meaning sharing a component between different single-page applications, meaning your application broken into different pieces. That was a long-winded digression. Sorry. But I'm very passionate about state and it being it being the enemy of finding true simplicity. So if you want simplicity in your applications, which you do if you're building a complex application, try to minimize your state. We want to tell the server something. Of course, we use XHR for this, right? If you just want to have a one-way conversation with the server, if you're having a monologue saying, hey, do something, just use Ajax, right? Use Post, use XHR. Likewise, if all you ever want to do is ask the server a question and have it give you an answer right then, stick with XHR. That's the right way to go. But if you want to get a notice from the server, then you have fewer choices. You can use something like Comet. I didn't even put it on here because it's you'll still see a lot of discussions about this thing called Comet, which is sort of an umbrella term for a whole bunch of technologies that we had to use 3 or 4 years ago because WebSockets didn't exist. Now we have WebSockets. We also have server-sent events. So if all you want is a steady stream of events from the server, you can use server-sent events to get that. If you want to have a conversation with the server, though, WebSockets is really the way to go. And for our other use cases that that are not showing up on here, I apologize for that. You can use either WebSockets to send messages to other clients, or you can connect to them using WebRTC and have real-time communication. But that means that you're bypassing the server, so we're not going to talk about that today. But if you're going to the main FITC event, I will talk about it a bit there. And it will be very exciting. We will all connect together directly, maybe. So how do you know when to use WebSockets? In general, you want to think of the 3 S's, speed, size, and state. So we already talked about state. Sockets are a way to maintain statefulness on the client. Using a full page reload as a way to get rid of statefulness on the client. These are both advantageous in their own way. Speed means both latency and frequency. So how fast do you need to get that information? Is a 100 millisecond delay important? Is a 1 second delay important? And how frequently are you going to be doing it? And then size means both the size of the data that you're transmitting and also the number of users who are doing this. How wide are you scaling? And your answers are going to depend on those. However, it will turn out that at least for your initial pass, using WebSockets to manage this communication with the server is a really, really good thing. So start with WebSockets. We'll see why in a moment. Oh, we'll see why now. So single TCP socket. That means you're not opening a new socket for every connection the way that you are with XHR. This just minimizes the amount of stuff your server has to think about. There's no header overhead, which is really good. Every time you send an AJAX request, you're sending a full HTTP header along with that. That's a lot of information. If you're sending tiny little requests and getting tiny little responses back, you don't need those headers. Use WebSockets, it'll save you a lot. But all of this is about performance and efficiency. And when you're first building your application out, just use WebSockets, A, because they're efficient, but B, because you don't want to think about this type of stuff when you're building an application. You just want to build an application. And then if you run into problems when you're scaling, you change the technology. It's pretty easy, and WebSockets give you a nice abstraction barrier between the way that you're communicating and what you're doing with that communication. Because you have that abstraction barrier, you can change to a different technology like SSE, for example, fairly easily if you have to, but you almost certainly won't have to. It's got good browser support, and it's got good sub-protocols, so let's look at those really quick. So sub-protocols are defined in IANA. That is hard to say quickly. There's a registry there for all kinds of sub-protocols. So WAMP is it's RTC plus PubSub, and you can run that over top of WebSockets, the WebSocket protocol. And because it's a protocol and not a particular solution, lots and lots of different libraries support this, right? So you can do remote procedure calls, you can do PubSub, and you can do that over top of this WebSocket layer. Stomp is a similar mechanism, but it's supporting MQ messaging. NoChan, OCC, OCPP, Mabooz, and a bunch of other things that aren't showing up. There's a lot of these, actually. And that's a really good situation to be in for this particular family of sub-protocols, that there are so many of them and they're They're officially registered and they're well supported. So it's good. You get all of these bonuses for free. But why Socket.io? That is a really good question. So my notes are written very small. So I've told you about this great WebSocket protocol. There's a couple of problems with it. Two big ones in particular. While it has really good support among modern browsers, it doesn't have very good support among antiquated browsers. So if your browser, if you have to support IE8, let's just be blunt about it, then you need to use some other type of solution than WebSockets. Also, there's no native WebSocket support in Node.js, and there probably never will be. So that means that we have to use something to handle those clients that don't handle WebSockets, and we have to use a library on Node anyway, or write our own, to wrap the WebSocket protocol and expose that from the server side. So if we have to do those two things, we might as well do it in the simplest way possible. And Socket.io gives you a really simple way to do it. It also gives you tons of niceties on top of that. It gives you a client that runs in Node, so you can do node-to-node WebSockets, server-to-server directly. You can do easy broadcasts. Your messages can be marked as volatile, which means you don't have to wait for this whole transmission loop. You can just fire and forget, and they don't get stuck on the server. So if you've got information that needs to go out, but it's not terribly important that everyone gets it, there's an option for that. Excuse me. It gives you automatic disconnect, reconnect management, heartbeats and timeouts, and a whole bunch of other things. Oh dear. At least the red on orange is not as bad. Callback acknowledgements, namespacing for multiplexing. These are all really good things to have that don't come in the protocol out of the box. So use Socket.io. It's got server support for all the languages you would want. And some of the languages that maybe you wouldn't want, I don't know. There are other libraries that do the same thing, but I would recommend that you use Socket.io, and if it turns out later in your project that you need to switch to another library, having that abstraction barrier there means that you can switch to a different solution fairly easily. And Socket.io is really simple. It's really easy to get set up. And it's really well supported. So even though I'm showing you this list of other things that do similar things, don't ignore all of this. Don't worry about it. Just start with Socket.io. Yes, that's what I just said. Thank you. Yeah, so I keep telling you how easy it is. Why don't we look at some code for that? How am I doing time-wise? Here's some code. I just want to point out a couple of things. Sorry, 20? Good, 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 good. Yeah, so we're listening on port 80. This is actually going to establish a whole new listener server using Socket.io. So you can do this out of the box, but most of the time what you're going to do is you'll have an app of some kind, and then you want sockets on top of that. So instead of putting a number here, you're going to pass your app in as a parameter to this. This is straight off of their webpage, by the way. I just thought I would point out a few things that will probably be different when you go to implement this. So this io.sockets.on is really important. This gives us a way to establish event listeners. So these are exactly like the event listeners that you establish on the client side for click events and all the other nice events. You get a few out of the box, like connection, disconnect, I think is another one. And then you can actually make your own also. So on connection, what we want to do is establish, so this is not formatted the way it should be, but we're going to pass our socket in, excuse me, as a parameter here. And then we're going to say socket emit, so we're using the socket object that we're handed, and that's going to send a message that is of type news and has this as its data. We can pass any object we want in as the data for that. It gets serialized, put on the wire, and then automatically deserialized on the other side. And likewise, we're going to say socket.on. So for this particular socket, which is a one-to-one connection from the server to this client who is just connected, we're going to catch this event. So socket.on means catch this event, socket.emit means send this event. And when we catch that, we're going to log that into data. Because we're on the server side, it's just going to log it into the console, or no hub, if you run that way. So this is the client-side code that we're looking at now. You can see down here, we are doing something very similar. We're just saying socket equals io.connect. We're going to connect it to localhost in this case. And then we're saying, when you get this news event, I want you to log that into the client's console. And I also want you to emit this other event. So this is just going to have a brief conversation between the client and the server as soon as you load this up. There's one more thing in here, though, that we didn't talk about, which is this. The first time you use socket.io, you're going to go and look for a socket.io.js file in your socket.io directory. And you're going to be really disappointed to find that that doesn't actually exist at all. So instead, what's happening is our server-side code over here, when you say listen 80, this is going to magically kind of make this, this root. And when you hit that, it's going to load the socket.js library for you. But that happens dynamically based on the properties of your client. You can actually host this file yourself, but it's a lot easier to just let it do it for you. It is a little confusing at first, but it's very, very simple. So just kind of ignore it, and then it's okay. Is there anything else on there? No. Oh, right, the other codes. Okay, let's see if this works. This is our live demo time. Matthias did such a good job. I'm a little scared to go after him. He's the live demo master. All right, what are we doing? So I want to show you maybe the simplest thing that I can, which requires getting out of full screen mode. There we go. Okay. So what's the simplest thing that we can possibly do? That would be to go to our terminal and actually run this thing. Okay, so we started up an app. What does that look like? That looks like this. Everything up here is just kind of your standard Node setup. So if you've used Node before, this is very familiar. I've just squished it for demo purposes. Can you read that code in the back? Good. This is our line that establishes socket.io. So we're saying require socket.io. We're feeding it the app, just like I promised you we would. And we're calling that IO. And then we're just going to do exactly the same thing we saw before, but this time with syntax highlighting. And we'll lock onto this connection event. And when we get a connection, we're going to establish a listener on that particular connection for an event called bounce. And then we're going to, every time we get a message to the bounce channel, you can think of these as channels if you want, then we're going to emit an event on the bounced channel. So why are we doing this? Well, we're doing it because in our client code, we're going to use this mystical socket.io.js thing, and then we're going to connect to localhost. And then we're going to listen to the bounced channel, and we're going to log that. Great, that's excellent. So what does this do in practice? Cross your fingers. Good so far. It's an empty page. That's good. Why is it an empty page? It's an empty page because the source looks like this. Don't do this in production. You should at least have some HTML tags in there somewhere. You know, maybe a doc type or something. But for a demo, it's probably okay. Okay. So we're opening up our DevTools, and we're just going to have a brief conversation with the localhost server. So we'll say something like socket.emit, and we're going to send this to the bounce channel, so it bounces to everyone who's listening, and we'll just say hi. Okay, and we get hi back out of our console log, so that's happening here. Great. I guess we can prove that this is happening here if we do this. I'm sure you all trust me, but we'll do this anyway. Just so you know, I've got nothing up my sleeves. And we're paused there, and if we ask what data is, then indeed data is high. Good, good, good. Does that work? Yeah. Okay, so can we send something more interesting? Maybe. Let's try sending some JSON. It's going to get serialized to JSON, but what we are sending is just a JavaScript object. And when it bounces back to us, you can see that it is actually a JavaScript object. So if we do that again, that's not going to work. What we would like to do is say something like this, but of course Q is just our socket because it's kind of this fluent interface where we can chain these emits after each other. And of course this is all asynchronous, so you don't actually get the return value that the server sends into the variable that you assign it to. Let's do something slightly more interesting, if this works. We'll add an event listener. I think I need a little more screen real estate. We'll grab the event that it gives us, and we will say socket.emit. We'll send this to the bounce channel, and we'll just send that event over, and we'll get that back, right? That should work, right? No problems here? Good, okay. Oh, I accept a syntax error. Dang it. All right, so let's test this out. Cross your fingers. And disaster. So why did that happen? Well, it's because the event that we're trying to send, if we dig inside here, is actually this nasty mousy event. And unfortunately, JSON stringify pukes when you try to stringify DOM events, so we can't do this. The moral here is that underneath the hood, Socket.io on both sides, on the server side and the client side, is going to use JSON stringify. So when I said you could send any object through and it would serialize and deserialize on the other side, what I really meant is you can send anything that you can JSON stringify, which, as it turns out, is not DOM events. They will crash your browser and your server, so don't do that. Instead, what we'll do with our fresh, brand new browser is just send this. All we really want is the coordinates here. And one of these. Okay, and now in theory, as I click, we will actually see this coming back to us. So this is making a round trip to the server and coming back. That's great. So what can we do with that? Well, if you all have your handy smart devices, it is possible that we can all play a game together. Maybe. Maybe. If the server is running. Okay. Crossing our fingers. So I think you can see this URL. Can you read that in the back? bentodojo.com:8802. Hey, that is awesome. So everybody gets a random color assigned. If you don't like your color, you can refresh the page to get a new one. Looks like there's about 3 people playing right now. 4, good, good. Okay. And the canvas is fairly small. You have to click on the canvas to actually make an event happen here. So what is the code for this? Like, that is exactly what I was hoping would happen. That makes me so happy. I had this running locally, and then I discovered when I got here that none of you were connected to the same network as I was, so I had to quickly get it running on an actual server out there in real space. Okay, so let's look at the code for this. This is our app. We're actually using exactly the same app here. We're just serving different HTML. So we already looked at this. It's just that bounce channel. That's all we're doing. Our server's completely dumb. Here's our HTML that we're loading. We've got our canvas tag up here. This time I actually have some HTML tags, but still don't do this in production. This is not what your production HTML should look like. We're just setting a hue. This is a fancy way to do math truncate because there is no math truncate function. Don't do that in production either. That's what these double tildes mean. That's just taking the... Well, you can do all of this socket IO stuff in production. It's just the surrounding code that I was minimizing. Yeah, good question. So we're getting our canvas context. We're calling that paper. We're getting our socket. We saw that before. We're listening on the bounce channel because we're using the exact same app that we used before. We're just serving different HTML. And all we're doing is filling that with our squares. We're using HSL colors because we can fix the saturation and lightness and then rotate through the hue. And in theory, that gives us something fairly pleasant looking-ish. Okay. And then this is our x coordinate and this is our y coordinate for the fill rect. They're always 20 by 20. We're just using this again as a cheap way of getting an integer. But in this case, we're dividing by 10 and multiplying by 10. So that gives us this effect where we can kind of set our squares next to each other, but not arbitrarily positioned. Is that off the screen? Oh, man. I'm minusing 5, so you lose a little bit here. Yeah, the minus 15 is just for accounting for the margin and the size of the square. And that's it. That's all we're doing. So I'm going to show you something now that will probably break this experience for everyone, and I apologize in advance. So I just want to show you the ease of Socket IO and how nice it can make things. Once I get a new Chrome, it pops up things in funny ways. Yeah, what are we going to do? We're going to do something like make a function. We'll call it X because I like single name variables for non-production work. And this X is just going to send an event. We're going to do exactly the same thing that we did before. We'll send something to the bounce channel so it gets bounced to everyone. And what we will send is our current queue, and then we'll use that, give us an int trick that we saw before. Since you've already seen it, I can keep using it. Then we'll say something like 50, and then we'll subtract. We'll say something like 100. No, we'll do 50. I'll be polite. And we'll just do that again for the y coordinate, and if I haven't made any mistakes, then this function, when executed, will do something. I've already made mistakes. We don't need this. So many mistakes. This worked a lot better in my head. All right, so no. What are we doing? We're sending an object, so that has to be there. That looks right, that looks right. Oh, live coding. Oh, I'm missing a, yes, of course. Oh dear. Yeah, I'm I'm using the fumble fingers technique for the closing things. Good. Maybe this will, yeah, okay. It put a square right up in the corner. I'm that dark blue that you're seeing over there. All of the squares are going to be here-ish. So now we're going to do something terrible. Oh, someone else just beat me to it. They're doing terrible things also. Good, good, good for you. All right, so here's our little robot that, in theory, unless I mess something up, I mess something up. Is this just completely dead? Did we destroy the... Oh, dear. Okay, so this... So my robot is working, but someone else's robot is working more efficiently. You can see them battling up here. Oh, dear. Yeah, so this is how easy it is to make a bot. If you're going to make a bot on your client, please be polite and only take up a small space or a long diagonal stretch. That's fine too. Oh dear. So this actually brings up a good question. Where should we put our logic in something like this? We're taking this client code and we're kind of bouncing things to the server here when you click, and then we're getting that bounce thing and we're filling something in. So on the client, we've got this completely dumb client, which is, sorry, on the server, we've got a completely dumb server, which is really nice in some ways, that our server is dumb, because it means that we don't need it. We could replace it with direct client-to-client connections, for example. We use WebRTC to make a connection of peers. The dumber the client is, or the server rather, is, the easier it is to get rid of it or change it out for something else. Okay. But we have a problem, which is that people are spamming our oh dear. Hey, there's some blue. Good, my bot's still running. I turned it way down. I set it to 1,000. Maybe I should have turned that up. I'll let you guys battle it out. All right. Yeah, so we've got this problem. Now, we've got some logic on the client side, which is great. On the incoming side, we've got this logic that says, take whatever the x-coordinate and the y-coordinate are and quantize them so that they're only every 10 pixels, right? You can't put something in between those. And you can't do that because even if you send me x and y coordinates that are in between, I'm going to quantize them before I display it. So we've got the receiving side on the client where we've got some logic. But on the sending side of the client, we don't have any logic at all. I mean, we're forcing you to send x and y and your hue when you click, but anybody who's in the console or anyone who's hitting your server directly can send anything they want here. So putting logic over here is a convenience. Maybe we can validate some things before you send them to the server, but you can never rely on that, ever, ever, ever. Because anyone can put anything on the wire they want. They could do rainbow colors instead of these. So that's your next challenge, botters. Do it with rainbow colors. Oh, dear. Oh, dear. I was going to ask, I meant to ask early on for a show of hands for people who were connected to this, so then you would know who to blame. I've forgotten that, and I suspect that people will not raise their hands now. Oh boy. Okay, good. So we can put logic on the incoming side, but we can't put logic on the outgoing side. Or we can, but it's only a convenience. So as much as possible, I would encourage you to put your logic here, although if your server is getting flooded, clearly you need to put some logic here. And Socket.io can help you with that, and there's other things that you can add on that can help you with that type of thing. But if you're getting DDoS, then you need a whole different level of protection. So there's kind of stages in here, right? So on our app, for example, we might turn this down so that from a particular client, we're only doing this emission. Like we're keeping an array of their last emit time, and we're only going to emit if it's been more than a second since the last time. That would stop most of the bots that are coming in now, although they could keep plugging away every second, or every 100 milliseconds or something, whatever you wanted. 2 minutes. I'm sorry. I kept looking over and yeah, we kept missing. Okay, 2 minutes. All right, let's try demo number 2. Oh man, there is so much stuff happening. This is never going to work. App colors, come on. So this is another thing that I meant to mention about Socket.io. It is extremely noisy, like extremely noisy. So you want to use the log statement to turn down the logging. I didn't do that so you could see how noisy it is. It will destroy your console and make it impossible for you to do anything at all. Speaking of which, if I can get a connection to the server, I will try running our second demo in 30 seconds. I will try running it locally, and then you can play with it later. So, where is that? Yeah, look at this. Okay, so this is a massively multiplayer game where you buy and sell Dogecoins, and as we buy them, the server's sending out a new price to everyone who's connected. If you were on the same network as me, you could connect, but I don't think you are. As you sell, the price goes up. And as you buy, the price goes up, and as you sell, the price goes down. And if everyone were playing together, then we'd see the price spiking all over the place. And the point is to buy when it's low and sell when it's high. Right? Yeah, do it that direction. So the code for this looks like this. There's a little bit of velocity that decays over time. We're just setting up kind of a random walk of size 10 every, I don't know, 300 milliseconds or something. That gets published out to everyone, and then you can buy and sell based on that. This is online, or rather the, oh dear, oh dear. The code for that is online. It's not running because the server's being flooded and I can't get a connection. So I will try to start it up soon. Somewhere in here is maybe my GitHub account. Oh, it's on this last slide. Yeah, that's a really good idea. The future. Socket IO 1.0 is coming. That's exciting. Let's do lots of real-time stuff. Universal WebSocket support everywhere, even on mobile. This is really good. IE8 is dying, so you can use raw WebSockets all over the place. Excellent. This is my info. And that code is all up here. So if you want to run your own server and have it spammed by people who are doing this, you can find that code on my GitHub account. And that's everything. Thank you. Yeah.